I'm Dr. M. Kamakshaya. I've been making a few video casts related to MS Excel. In my previous video, I explained about certain trivial exercises using GoalSeek in MS Excel. In this video, I'm going to talk about how to use GoalSeek for a particular yet potential concept called eigenvalues. Now, what is this eigenvalue or eigenvector? In business statistics or in computational statistics, eigenvectors, eigenvalues has huge importance because this concept is being used in several analysis such as principal component analysis, exploratory factor analysis, multidimensional scaling, correspondence analysis, etc. etc. Now, what is this eigenvector? This eigenvector is a characteristic vector, and eigenvalue is a characteristic value. So what is this characteristic? This is the nature of the data. Usually in statistics, we use this eigenvalue as a covariance, as a measure which describes the covariance, and eigenvector as a component, a latent variable or maybe hidden factor or something like that. So usually eigenvectors are treated as components, dimensions, factors, and eigenvalues are treated as measures that do speak about the importance of a component, that which preserves the characteristic of the data set. Now I have a simulated data set in my Excel sheet. I just used rand between to simulate this data. So I'm just going to freeze my values. Now in order to find, as I have said, this eigenvector and eigenvalue, both of them deals with a particular aspect called, usually when we talk about the characteristic of a data set, it is all about variance. Now what we are trying to do is that whenever we find an eigenvalue, this value is a measure that speaks about the variance in the data. Now variance is one of the potential measure that speaks about the base characteristic of the data set. So the variability, variance, and deviation, it's one of the very important measures of base data. So whenever we have a data variable or a data matrix or data set, we speak about the nature of the data by calculating the variance or covariance or variance matrix, covariance matrix, or something like that. Now to calculate the eigenvalue for this data set, let us assume I here taken the column names as x1, x2, x3, but it can be something like age, gender, salary, or satisfaction, attitude, perception, whatever it is. Now the first step is I'm going to talk about, as I have said, the eigenvector or eigenvalue, the eigenvalue which I am going to show you how to calculate in this video cast is something to deal with the covariance matrix, right? So in Excel we've got a data analysis tool pack, and I'm going to use my data analysis tool. I can also do it manually, but I wanted to make my job rather easy. Covariance matrix. Now where's the data? So my data is in Excel has found my data in an exact way. I have labels in my first row, and then I want the output range in E2. Yeah, of course, okay, fine. E1 I take. Now something went wrong. Okay. So output range, I think my input data is wrong. So let me take this is my input data. Output range E2, no, not E2, I don't know why it is taking E2. It should be E1. Okay. Now I got my covariance matrix, but this should not be the one. See, my x1, x2 value is this one. I'm going to fill rest of the value. x3, x1 value is this one. And now x3, x2 value is this one. So this is my base matrix. It is a covariance matrix, which is a characteristic matrix of my data set x1, x2, x3. Now the procedure is going to be like this. So I will explain how to find the eigenvalue using so for a base matrix A, for a base matrix A, so usually it is like Ax is equal to lambda x, given lambda is an eigen value. Now if I divide this both sides with x, Now A is equal to lambda x inverse. And now this x inverse can be written as identity matrix. Now going further, so if I have to take this lambda I to the left side, now that is going to be my determinant of A minus lambda I is equal to 0, since they are matrices. So why determinant is because if it is just a simple algebraic equation, then A minus lambda is equal to 0. Because these are the matrices, I should write determinant A minus lambda I is equal to 0. So now this is the base calculations which we require to perform in Excel in order to find the so I need identity matrix, and this is, I have to select the same order. This is a array operation, MU array, that is I want 3 dimensions. This is identity matrix. Now the expression is going to be AI minus lambda. So I'll take some rough value for rough guess for lambda. I call it as Y lambda. I take 1, and now A, this is my A matrix, minus lambda times identity matrix. So this is the expression. Now this should be an array matrix. Okay, so I need to solve this for determinant. We have a function mdeterm. So determinant of this matrix is going to be 0. Now this value should be 0. So how are we going to handle this? This we can do easily with the help of goal set. Now this determinant of A minus lambda I need to be 0 by changing the cell lambda. So what should be my lambda value if the determinant of this A minus lambda I need to be 0? So now we can, so this is, so the determinant is close to 0. It will be never 0. It will never be 0. So it is very close to 0, and it is 0. So my lambda will be 1.93, which is a fair value. So this covariance matrix, okay, this lambda value represents this covariance matrix. This covariance matrix is a better characteristic. I can say that it explains this data set in a fair way, okay, or a better descriptor of this the base data matrix. Okay, thanks for watching this video. Stay tuned for the new content. Bye bye for now.